This is going to be introduction level for our MongoDB Atlas search presentation. So welcome back, Bart. Your stage, it's here.
Thank you very much. Thank you very much. So some of you might have seen the advanced Atlas search presentation that was, I think, just before this one on the second floor. If you're totally confused, this is the level 1 or level 0, just an introduction to what Atlas search is. So what do we mean, first of all, by search? It's not that one morning we lost Atlas and we had to search for it. It is really a function in Atlas. So it is a function that allows you, your applications to feel modern. Modern applications very often have some kind of search functionality. So this could be something like suggestions. You start typing something, and you get a list of suggestions to make your life easier. So you don't have to type it exactly what you want or type even the whole thing. It could be something like auto-completion of names. LinkedIn, I think most of us have used LinkedIn. It can be highlighting. So in this example, it's just the search integrated in the browser, but very often you have highlighting of results to see what has matched. Or it could be even relevance-based results. So you do a query to the database, a search query, and you get the results not based on how recent they are, how many stars they have, but how relevant they are to your search. So all of these functions are quite difficult to implement with a traditional database, even with a very cool, very modern database like MongoDB by itself. So what are the functionalities that we're looking for that the database or the platform has to provide? First of all, we need to do fuzzy search in order for this feeling of a modern application, that the application is helping us. If you make a typo, for example, in Google, Google will know what you mean. We'll say, OK, this thing that you typed, it's not exactly right, but I have a lot of results for this similar thing. Then, if you have fuzzy search, it helps a lot to have highlighting. So you're getting a result, and it's not really clear why you're getting that result. So you can highlight the part of the search that the database or the data platform thinks that you're looking at. Another two very important functionalities that normally databases don't provide are, first of all, facets. So you go on Amazon, you look for TV, and automatically Amazon creates a menu on the left based on the results that it already has with facets. So with attributes that the documents that matched have, that you can filter to refine your search a little bit. And you can see here in the middle that you're looking for a TV, but Amazon magically presents a product that is not a TV, that is the Fire TV. However, it is there, and it is in the first page of result. So they really want to boost really the score of that result because it's their internal product. So the scoring has to be adaptable. So we talked about relevance search. That relevance can be also boosted somehow, so you can manipulate the score of that relevance. So all of these functionalities are not in traditional transactional databases, be it Mongo, be it any flavor of SQL, or in a number of other NoSQL databases that allow transactions, provide asset guarantees, etc. So if they're not there and the products exist, so the application exists that they use this, how it's usually done? How usually you implement these kinds of applications? So first of all, you have your transactional database. All right? So you have your functionalities that are typical transactional functionalities, checking your balance, viewing your history, your purchases, looking at your wish list, looking at your returns, things that are very, very deterministic by IDs or by exact matches. So the functionalities that you need for this, that a traditional database, a transactional database provides, are CRUD operations, change streams or CDC, aggregations, it could be secondary indexes, ACID transactions, a number of functionalities that you need for your transactional workloads. So that is something that you have as table stakes, basically. You assume that the database has that. And then you need your fuzzy searches. So you need a second data store with a search engine. So this could be your Elasticsearch or Solr. Usually all of these products are based on an Apache project called the Lucene project, which is a Java-based library that allows you to create these inverted indexes. Cool. So that is the functionality that powers your search bar. Almost just that functionality, almost exclusively just the search bar. And this brings all of these features that we saw. So your autocomplete, your fuzzy matching, the facets, something like that we haven't seen yet, but synonyms. You're looking for a car, or you're looking for a vehicle, and you find a car and a truck and a bicycle. So it needs to interpret a little bit human language. And then, as we saw, the scoring and weighing. So those are two separate sets of functionalities that both have, that are mutually exclusive. So the traditional database doesn't offer fuzzy matching, and Lucene doesn't offer CRUD transactions or ACID compliance. So you need both to work together. And if they both need to work together, we need a third element in the equation, some synchronization mechanism, some ETL, something like that. So you have a database, a search engine, and some mechanism to synchronize them. This, of course, has quite a lot of overhead. So different APIs, the way that you query your transactional database is different than the way that you query your search engine. There are bound to be synchronization errors. You have to configure firewall rules. You have to make sure that everything is secure. So myself, being security-oriented, if I have to find a hole in the system, I would definitely look into the synchronization. If something there has, somebody has left a door open, has forgot to close something. And finally, you have your database and you have your search engine. So you have two sets of machines, of instances, of data replication. So basically, you have a copy of your data, two copies of your data. So one in the transactional database, one in the Lucene index. So quite a lot of infrastructure. So this, I mean, works. It has some drawbacks, but it works. But we can do it better with Atlas Search. So what do we offer with Atlas Search? With Atlas Search, we offer all of these functionalities just in one product. Surprise, surprise, in Atlas. So in Atlas, we have the traditional database. The traditional database, of course, Mongo. Yeah? No surprises there. And then we integrate the functionality of the search engine. So you can, with having your data in Atlas, you can have all your transactional features, so CRUD, change streams, aggregation, etc. Plus, then, on the other hand, the fuzzy matching, all the search functionalities. All in one entity, in one product, in one service. So what does it mean for the application? When we are writing the application, when we're querying the database, we don't need to have two separate sets of APIs, two separate sets of connections, and worry about synchronization and stuff like that. The application just talks to Atlas, and it can do transactional things, and it can do search queries. This means that developers don't have to learn a second technology. Ops people don't have to learn a second stack to maintain. The architecture is simpler. The synchronization, I mean, it doesn't go away. It's still somewhere there, but you don't need to maintain it anymore. And it is fully managed. So everything is offered to you as a MongoDB database was in the past. Right? So what are the features that you get with it? We saw a wish list of features. do we have all of these features included in Atlas? So let's take a look. First of all, just to explain how this works a little bit under the hood, I mean, it's still an introductory presentation, we need to talk about analyzers. So analyzers are a function in Lucene, in search engines, that take a text like lions and tigers and bears, oh my, and translate this to something that Lucene can index and then search for. So analyzers, there's a lot of them, and they apply some rules that make it useful. So in this case, we're going to apply the rules of the English language. Right? So in the middle layer, you can see that we have eliminated the capitalization. So lions is written with a small l. We have eliminated the word and, because it doesn't give us any semantical meaning. Nobody is going to search for and, we assume. Otherwise, we need to use another analyzer. And we have eliminated punctuation. So after the analyzer has parsed the string that we have given it, we are left with tokens. So tokens are semantical units that we want to index, that we're assuming that our users are going to search for. And if we're parsing a human language, like English, we can be a little bit clever. And for lions, we are not going to store lions with an S, because somebody can look for lion or lioness, and they should find this as well. So the analyzers can also find the stem of the word. So if we have stored or we have indexed shard, the analyzer can also return or modify our search term and the input term. So shard and shards and sharding and sharded, or lion and lions and lioness, they all go to the same root of the word. So this is what powers this intuitiveness of the search engines. So the analyzers apply the same for the input string, so the content of your database, and the queries that you send. They apply the same tokenization, the same rules to find the tokens in both the query and the content of the database, so they can match and give you the results based on that. So we have talked about English. Most of you here speak 2-3 languages. So what happens if you have more languages in your application? Well, we have 30-something languages. I think it's 38 at the moment. So we have analyzers already ready for those languages. I mean, when I say we use the ones provided by Lucene. Right, so Lucene, as an open source library, already has those analyzers that we are using. So then we can analyze the text to apply the rules of certain language. So if the language is the text is in English, we're going to drop the ands and the ors. If it's in German, we're going to drop the unds, etc. So we can find the relevant words and reduce them to their core, so we can then find variations of that word. Then we have autocomplete. So this is for normal text in which our analyzer is creating tokens of whole words. So if you have shard, it's going to, or sharding is going to generate the token shard. But that doesn't work for autocomplete. If we have, for instance, shard in our database, and the user is typing SHA is not shard. It wouldn't fit. It wouldn't find it. So if we want to do autocomplete, we need a different type of analyzer. An analyzer that breaks the word into different groups of letters. So if we input shard, it will store it as SH, as SHA, as SHAR, and the whole word SHARD. So when we start typing and we have 3 letters, it can already see where we're going. Of course, there's other words that will also simplify it to SHA, shaft. So if we write SHA, it will auto-suggest 2, 3, 5 possibilities. All of the words that have the root with that group of letters. So this is a specific feature that the analyzer or the search engine has to support, has to offer in order to implement autocomplete. And it would be possible, of course, to implement that ourselves. So we go through all of our data and we tokenize it and we simplify it. But Lucene does that for us, so you get that out of the box with Atlas Search. So then we have highlighting. Highlighting, as I mentioned, you're looking for some terms. Maybe you made a typo that we'll see in the next one. And you get a whole wall of text. Like here in Google, it brings results from the Wikipedia. And if you look for Harrison Ford and you get, as a result, Air Force One, you might say, hey, why am I getting this result? It's not called Harrison Ford. Right? So just to bring your attention to the element that matched, you can do highlighting. Of course, you can do the highlighting in software, as with many things, but it would be much easier if the database shows you why it matched this. And this becomes even more useful if we later see like fuzzy matching and synonyms. That you looked for something and it is matching a completely different thing, but that it thinks that it's relevant. Or you can tell your application to match it because it will be relevant for your users. Then, as I mentioned, fuzzy matching. So if you have a database of movies and you have Air Force One with the cast and you have Harrison Ford, if some of your users look for Harris Ford with a traditional database, there will be no matches, because it just doesn't work. That's not how indexing works in transactional databases. So Lucene offers us the possibility of having edits, of calculating distances between words. So we can, at query time, we can say, OK, be a little bit tolerant to typos with this query. So this is something that you see very often in Google, that if you do some typos, it says, hey, did you mean this? And it actually not only shows you the results, but actually autocorrects your query. So not Harris Ford, but did you mean Harrison Ford? Because I haven't found many results for Harris Ford. Again, something that you really need support from the database to do this. This will be very, very difficult to implement it in a traditional database. So that's why we have the Elasticsearch or separate databases if we don't use Atlas Search. Then we have faceting. So as I mentioned before, you go to Amazon. This is the best example. And you search for something, and automatically, adaptively, on the left, you get a menu of other attributes that all the products that have been found have in common. It can be sizes, reviews, years. Sometimes you have this also searching for movies with the cast, with the directors, with IMDb scores. And then you can refine your search without having to write the categories for each one of the products, or the attributes for each one of your categories. Then, if we have everything integrated, and we're using MongoDB as a transactional database, then we have multiple data types. So our search engine has to support all those multiple data types. Good news here, with Atlas Search, everything that MongoDB supports, arrays, GeoJSON, decimals, all of that is supported. Object IDs, you can do autocomplete an object ID if you want. It is definitely supported. Then we have synonyms. So this is a little bit more advanced feature, but very useful, that if you have something that you know in your application, you can define synonyms if you know the language that your users are going to be using. And with language, I don't mean English or German, it's domain-specific language. So that's why the synonyms don't come out of the box. You have to define the synonyms, because this is something that wouldn't work as a general rule. So we have some examples here that we have two mapping times. We can define an array of synonyms that are all equivalent to each other, with car, automobile, and vehicle, or just in one way, that beer, a synonym is brew or pint, but pint doesn't find beer, because you might be talking about measurements. So this is very domain specific. If you have an application for a prison system, for instance, then running and executing are very different things. If you have an application for customer support for an operating system, then running and executing are basically the same thing for a program. So the domain language is very important. That's why you need to provide the list of synonyms for the application. And then with the fuzzy matching and the highlighting, it creates a whole different user experience for the end user of the application. That they are looking for a ticket. Okay, this crashes when I execute this command, and then it finds a ticket with a crash when I run this command. So really relevant to the application. And finally, we have scoring. So usually, if you don't say anything, the results are highlighted, or they are sorted by relevance. Relevance, it's a really complicated way that Lucene has to give it a score of how relevant this is, based on the contents of the document, of the contents of other documents, on the length of your query. So there's a lot of statistical analysis there, and it comes up with a number. This number you can boost or change to give it different meanings to your application. So for instance, you can boost the search by the number of reviews of a restaurant. So, or the average review of your restaurant. So better restaurants come a little bit better on top. However, they still have to be relevant. So in this, with this mechanism, you can fine-tune a little bit the results that are presented to the end user. So the two steps that you need to do in Atlas to use these features are quite simple. So I have prepared a couple of videos to show you. First of all, how you create one of these indexes. So in Atlas, you just go to the expanded view of your cluster, in which you can view the collections that you have. In this example, we are going to use one of the sample data sets. Maybe you have seen it. It's some pseudo Airbnb database. Right? So you have descriptions, you have locations, you have lots of data. So on this collection, we would like to create a cluster. Right? We would like to create a search index. So we have a lot of text in here. In this case, it is all in English. So to create the search index, we click on the Search tab on the top, and there is a button there. We click on the Create Search Index button on the bottom. And then we have two options, a visual editor and a JSON editor. So the first 5 or the first 10 indexes that you create, you're going to use the visual editor. We will do the demo with the visual editor, but afterwards, the JSON editor is there for you to use to copy-paste or to automate this somehow. You select the database and the collection. Where do you want to create the index? So in this case, the Airbnb database, and you select the analyzer. You can select the index analyzer and the search analyzer separately. Usually, they should be the same. You can refine the index, but we are going to leave everything on automatic. So it uses what we call dynamic indexing. So it indexes all of the fields in the document. So if we have new fields that we add to the document, those will be indexed as well. So if you don't have a predefined schema, you don't need to change your index. However, be advised that this will create very big indexes, because it will create an inverted index of all the words that you're storing in your collection. So once the indexing is done, we can query it. So to query it, let me go here. There we go. So once the index is created, you can see here that the status is active. It has indexed all 5,000 documents. We query it using the normal aggregation pipeline. So with Atlas itself, you can test it a little bit to see how it works. So you have your collection, a preview. You can type here, for example, the name of a city. We want to find something, or hotels or Airbnbs in Porto, in Portugal. So you just write Porto with a capital P, and it finds documents with Porto with all capital letters, all of that. Then we can export this query. We can choose our language, and immediately this is something that we can copy and paste into our application. So it is quite easy. Of course, you can customize this. You can add it. This is part of the aggregation pipeline. You can add more stages if you want. But the basic example, that's how it works. And it can be as easy as that. So finally, just to recap, is what is Atlas Search? So it is a functionality that is included in Atlas. It is, I think, easy, and it's quite fast. It automatically updates your data. It does automatically sync it, so you also keep data consistency. If you create a document, very, very fastly, it's available in the search. It's reliable because it's all inside the same machine. It scales with the cluster because it's in the same machine. So if you scale a cluster, the Atlas Search will also be scaled. Although we have seen here some very basic examples, it is highly customizable. You can tweak a lot of the parameters there. And we hope that it will be something that you will use to improve your application, so add some search functionality. If you want to do that, you can just go to Atlas and start tinkering with it, of course. But for something more guided, we have prepared a website, atlassearchworkshop.com, in which you can see some examples, some guided tours, and of course, you can also talk to us, to your sales guys, to your SAs, to whoever is your usual contact at MongoDB, and we'll be very, very happy to help. So that was it for a short introduction to Atlas Search. Again, you've heard this many times. Please give us some feedback if you liked it, if you didn't like it. Just scan the QR code, and if you have any questions, I'll be happy to take them.
Thank you very much. Is there any question on the... Oh, wow. Who was first? You were first.
Yeah, hi. I have a question regarding running Atlas Search. Is it better or worse running with serverless Mongo? Or is it like, what is better to have? Like my dedicated Atlas instances or serverless instances? How does it have any effect?
So it shouldn't affect the way that Atlas Search works. Mainly your transactional load should determine whether you want to use serverless or dedicated. Search should work anyway.
Okay, so enabling it doesn't have like any visible effects. Oh, great, thanks.
Can you pass the microphone?
Thanks so much. I have two questions. First, the question that I would like to ask, how it works if we have multilingual database and current session in the browser right now activated the German language and we start typing like Apple. Do we get the result like Apfel, or it works only with the exact language which already activated on the session?
So the language configuration you have to explicitly set. So once you get the query Apple, you could translate it, but that's, yeah. But you have to even determine if you have multiple descriptions in your document, one description of a product in German and in English, and which analyzer do you want to specify. So that is something that the database doesn't do automatically, it doesn't detect the language. It just allows you to have multiple languages simultaneously and to define the language that you're going to to search with. But it doesn't do the automatic detection if Apple, if you meant an apple in English or you're looking for Apple stores in Frankfurt. Right? So it doesn't do that detection. That's something that you explicitly, as a developer, have to decide how to do.
Okay, and second question about the contextual things, which you already mentioned about. For example, we have a request in the Google where we start typing like Eclipse, and the Google at the moment doesn't know which exactly should show. For example, we have a programming IDE, we have a nature phenomenal, we have a movie which calls as well, Eclipse. And the question is, which will be first, or the first place, how it calculates the score for this kind of request?
It's black magic. It's what Lucene uses, so it depends on the contents of the database. Not only of the document, but you can search Eclipse once, and after the next crawling or an update, you insert another document in the database which talks about cranberries, and you look for Eclipse, and suddenly the statistics has changed slightly, so you get a different ordering. Because now the lengths are different, and it is very precise, very sensitive to those changes, so it can change. So if you want some specific thing, you can use the explicit boosting to make sure that you get the results in order. But other than that, there's a whole paper also from Lucene with mathematical formulas, but those mathematical formulas are very sensitive to the frequency of each word. So even if the word that you're looking for is not in the new document that is inserted, it has changed the relative frequency of all the words that you are looking for.
Okay.
Yeah.
Thank you so much.
I think there was...
There was a question here.
So you talk about like this fuzzy search and the typos and correction, but isn't it like the job of the algorithm on the application level to do that? Because I think the database is a different topic, right?
To do what, excuse me?
The fuzzy search, like
Yeah.
the correction. So isn't it the job of like the algorithm or the application layer to do?
No. You don't need to do anything in the application layer. You just need to specify how sensitive do you want to be to typos. Basically, how many typos do you want to allow? How many missing letters do you want to allow? Because if you allow too many missing letters, you are looking for BMW, but you get a Mercedes. You get something completely different because, if you change all of the letters, this result matches. So you have to, as a developer, say, okay, we are going to allow 3 changes. 3 typos, or we're going to allow 1 typo or 0 typos. So that's the only parameter that you need to do. To give it, you have a couple of other parameters, like we're not allowing typos in the beginning of the word, but because who would do that, right? Because usually the first few letters are correct. So it's totally parameterizable. You can give it some parameters, but other than that, then the database takes care of everything like that. And then you just get a list of results with the typos corrected, so to speak.
Is there some configuration as well for this correction?
Yes. So there's a couple of parameters that you can set up. If you want more, you would have to really look into specific analyzers or something like this. So there's a lot of things that you can adjust to get exactly the relevance still, but the tolerance to typos that you want.
Okay. Wow, one more. On the end.
Okay, maybe just a practical question. How does it work if I really switch on this feature and I misconfigure it? Like you said, you're querying about all the fields or you're analyzing all the fields. Could that, is there a warning if it just explodes costs or something?
Good question. So the cost will usually not explode because the feature itself doesn't have any cost attached to it. So it just in your machine, it creates an index. So all the usual Atlas warnings, metrics, and alerts apply. So we'll start getting alert, hey, you're running out of disk, your CPU is over 90%. So then you can decide to autoscale, enable autoscaling. That would have some cost. But the feature itself, it just generates more usage of the resources that you already have in Atlas.
Okay, and there's a second question for the synonyms. Can I put them somewhere, or have I to define it at the level where I use the analyzers or something? So like putting all the synonyms in a collection.
Can you repeat the question? I didn't understand.
Okay, it was like, can you put the synonyms, for example, in a collection dynamically?
Yes, that's how it works. You create a specific collection with the synonyms, and you tell the indexer and the analyzers where the synonyms are in a collection inside MongoDB, the cluster itself.
Okay, and I can modify them.
Yes, it's dynamic.
Okay, cool, thanks.
Okay. So that was the last question for this part. And
If you have more questions, I will be in the booth here.
yes,
You can just reach out to
we
me
are
later.
there. Thank you so much, Bart.